So we're going to use the fractional exponents to get these guys into a final radical expression. So we know how to do this, right? We start out and we put the 8 like this, and we make the fourth root a 1/4. And then we're going to put the 5 like this, and then make that 3 be a 1/3. Okay, so now we're going to do we can't do like before when we had the same base on both, right? If they were both x, or we had one where they were both 7, then we could just add the exponents. But these guys are different, right? The 8 and the 5. But we're still going to use a technique here. This is another thing that you have to know, another technique, where we are going to come up with a common denominator for these guys, and you'll see exactly how this works. So the common denominator for these is what? A 4 and a 3? Common denominator would be a 12. Correct. Okay, so that means we're going to have the 8. Oops. We're going to have the 8, but we want this. We want a 12 for our bottom guy there, our denominator. And then we're going to have a 5, and also we want a 12 for our denominator. So here we go with this old thing. What do I do to a 4 to get it to be a 12? I have to multiply it by a 3, right? Therefore, I would also multiply the top by 3. And then it's the old, what do I do to a 3 to get it to be a 12? I guess I have to multiply it by 4. So that means if I'm going to multiply the bottom by 4, I need to also multiply the top by 4. Hooray! Get out of there. Okay. So therefore, I've got my 4 times 3 gives me a 12. Up here I have a 1 times 3, so that's just going to be a 3 right there. Here's my 3 times 4 gives me a 12, and 4 times 1 is going to give me a 4 up here. Now, here is the reason those numbers are so high that you saw in some of those answers. Here's the way we're going to do this. We're going to keep the powers with their buddies. So this cubed is going to stay with the 8. And the 4 is going to stay with the 5. But what we're going to do is pull out the denominator, the 12. And so the way that's going to look is this. We're going to have 8 cubed times 5 to the 4th, and all of that to the 1/12. See how that works? And so how do you always check that? We just multiply it back again, right? We say 3 times the 1/12. That gives us 8 to the 3/12, right? And we say 4 times the 1/12. That's the 4/12. There's the 5 to the 4/12. Okay? So now the final step to this is to actually figure out 8 cubed and 5 to the 4th and take the 12th root of it. So it means this. 12th root, right? That's what we get out of the 1/12 of 8 cubed times 5 to the 4th. So now we actually have to compute those. Okay, so that means, let's put this over here, we need 8 cubed. Well, we can look on our paper. Okay, we find the 8 on the right-hand side, right there. We see the cubed on this side, 512. Okay? Or we can say this, 8 times 8 is 64 times 8. Okay? 4 times 8, 32. Down the 2, carry the 3, it. 6 times 8 is 48, 49, 50, 51. I always count the extra little points there on the 3. So there's the 51. And sure enough, 8 cubed is 512. So there's 512. And then 5 times itself 4 times. Okay, we can look on the page, but we can also just go 5, 5, 5, 5. We can say here's 25, here's 25, right? So we can say 25 times 25. Okay, so 5 times 5 is 25. Put down the 5, carry the 2. 2 times 5 is 10, plus the 2, 12. Okay, then we have 2 times this 25 is what? 50, right? So 50. So 5, 2, and 6. 625. So now if we look at this, we're looking at the 12th root of those two numbers multiplied together. OMG. So who's got a calculator? Who's got the C word? What's 512 times 625? We could go into Google and type it in right away.
12,800.
Is that what it is?
So I did the math on.
I don't see that as being one of our answers here.
320,000.
There you go. You mean like that? So the answer here is what? The 12th root
My math.
of 320,000.
Oh, I didn't do the, never mind. I didn't do the third number.